Hello guys, in this video I will be discussing Module 3 Lesson 1 which will tackle dynamics. Okay, the title will be Newton's Law of Motion. Okay, so all of my discussion here will be based on the book of University Physics with Modern Physics 14th edition by Young and Friedman. Okay, so uh, in this topic, we will focus on force and interactions. Okay, so when we say force, it is usually defined as a push or a pull. It is an interaction between two bodies or between a body and its environment. So there are two types of force: the contact force and the long range forces. When we say contact force, it involves direct contact between two bodies such as a push or a pull of an object by a hand. Okay, when we say long range forces naman, usually it is uh, the two bodies are separated by an empty space. However, there is a force which acts between them. Okay, so ayan, there are different forms of contact forces. It is the normal force, friction force, and the tension force. When we say normal force, um, it is the perpendicular force exerted by the surface to an object. Okay, so for example, you have an object placed on top of a surface. Automatically, there will be a normal force acting on it. Okay, perpendicularly on the object, perpendicular to the surface. Okay, so this is the normal force. When the surface is inclined, the normal force will be still perpendicular on the surface. Okay, so there is what we call frictional force. If the normal force is perpendicular, okay, the friction force is parallel to the surface. Okay, so ayan, friction force yan. Frictional force and the normal force is always perpendicular with each other. And then lastly, we have what we call tension force. When we say tension force, it is the force, the pulling force exerted by a rope, by a cord. Okay, so usually, this is seen in pulling an object or hanging object, ganyan. So, lastly, we have the long-range force, diba? One form of a long-range force is the weight, which is the pull of gravity on an object. Okay? So, an object with a mass and placed on Earth has a weight equals to the mass times the gravity, or 9.8 if it's on the surface of the earth. Okay, so ayan, so force vector, in order for us to describe the force vector, we should determine first its direction and magnitude. So for example, here in this image or in this illustration, we have a pulling force which is 10 newton and 30 degrees above the horizontal forces going to the right. Okay, dito naman is we have a pulling force 45 degrees above the horizontal, going to the right downwards. Okay, so ganyan siya. That's how you describe uh, that's how you describe a force vector. So etong pababa, 10 newton, push directed 45 degrees below the horizontal. Ayan. So, ito naman is above the horizontal. This one is below the horizontal. Okay. So, superposition of forces. Sabi lang dito, if an object is subjected to number or numerous forces, it is also equivalent to a single force, which is the summation of every forces. Okay, so parang any number of forces applied to a point on a body have the same effect as a single force equal to the vector sum of the forces. So if we will get the resultant of all the forces acting on on the object, okay, it is also equivalent to the resultant force. Ayan. So the resultant force is equivalent to the summation of forces F1, F2, and F3. So, yan, let's apply that in example number one. Three professional wrestlers are fighting over a champion's belt. The figure below shows the horizontal force each wrestler applies to the belt as viewed from the above. The forces have magnitudes 250 Newton. Ang F1 natin is above the horizontal. Okay, directed above the horizontal, which is 50 degrees above the horizontal. Ayan. Ang F2 natin, 50 Newton, is going to the x direction. F3 is going to the negative y direction. Find the x and y components of the net force on the belt and find its magnitude and direction. Okay. So, let's solve it. So, di ba sabi dun sa superposition of forces, the summation of forces is equivalent to the uh, is also equivalent to a single summation of the force or the resultant. So the resultant is equivalent to F1 plus F2 plus F3. Ayan. So in order for us to do this, we have to get first the x and y components. So yung F1 muna, we have the x component of F1, which is equivalent to we have 53 degrees here above the negative x, so we have to get the angle from the positive x direction, positive x counterclockwise direction. So 180 minus 53, that is 127 degrees. So F1 is 250 Newton times um, cosine 127 degrees, and F1y is equivalent to 250 sine 127 degrees. Yeah. So let's compute for it. 250 cos 127. So that is equivalent to negative 150 Newton. And then 250 sine 127. That is equivalent to 200 Newton. So basically, ayan, tama siya kasi negative x and then positive y. And then we have to get the summation of x components. That is negative 150 for F1x. Then F2 is positive 50 Newton. F3 walang x component, so this is negative 100 Newton. And then let's go to summation of Fy. Ayan. 200 Newton minus F3 na 120 Newton. Bakit minus? Kasi going downward. So, this is equivalent to 80 Newton. So, this is the X and the Y component of the net force. And now, we get the magnitude. Okay. To get the magnitude, we have to yan, negative 100 squared plus 80 squared. So the net force is equivalent to 128. Okay. 128 Newton, and the direction would be um, 80 over negative 100. 80 over negative 100. Negative 38 or negative 39. Okay. Now, if we will have the final answer, this is 128 Newton. Okay. Um, 39 degrees. 39 degrees um, above, directed above, oops, directed above the horizontal. Yan. Or simply 128 Newton. And then, you get the complementary, the supplementary if this is 39 degrees. Ito yung 39, di ba? Kasi positive y and negative x. So, 180 minus 39, 141 degrees from the positive x-axis counterclockwise. Ayan. So, ganyan siya. And then, let's proceed to the next topic, which is the Newton's first law of motion. Sabi dito sa Newton's law, first law of motion, a body acted on by no net force has a constant velocity which may be zero and zero acceleration. In other words, an object at rest will remain at rest, or an object in motion will remain at motion, uh, unless otherwise uh, acted upon an external force. So, for example, walang external force, okay? So, kung ang object mo is initially at rest, it will remain at rest, okay? But, and if your object is in motion, okay, at constant velocity, it will remain at constant velocity kapag hindi siya acted upon an external force. So, summation of F is equals to 0. So, ganun lang siya kasimple. Okay? So, sa second law of motion naman, ito naman yung uh, kabaliktaran. If a net force acts on a body, the body accelerates. Okay? The direction of acceleration is the same as the direction of the net force. The mass of the body times the acceleration vector of the body equals the net force vector. So, kung kanina is at in equilibrium siya, in equilibrium state na kung nasa rest siya, it will remain at rest, or in motion, it will remain in constant velocity. Dito naman sa second law of motion, kapag acted upon external force na siya, it will make the net force will make the body to accelerate. Okay? At yung direction ng acceleration is the same with the direction of the force. Okay? So, summation of F is equals to MA. So, ganun siya. Okay? So, lahat x component is equals to MA, y component of F is equals to MA, and the z component of F is equals to MA, which is also their equal, yung direction ng acceleration natin is equal to the direction of the forces. Okay? So, in example number 2, a worker applies a constant horizontal force with magnitude 20 Newton to a box with a mass 40 kilogram resting on a level floor. So, with negligible friction. So, sabi niya, meron siyang box, and then a worker applied 20 Newton force. Tapos, ang box natin is 40 kilogram. Okay? What is the acceleration of the box? So, dahil meron siyang binigay na force, okay, then it is equivalent to MA. Okay? Kung titingnan natin kung free body diagram tayo dito, FBD. Ang FBD ay free body diagram. Ayan. Ito yung ginagawa kapag nagmo-model ka ng mm, physics system, okay? So, halimbawa, ito si object. Siyempre, di ba, meron tayong tinatawag na normal force, okay? And then, meron din tayong tinatawag na frictional force, okay? However, ang frictional force dito is sinabi niya negligible, so wala na to, okay? And then, ang movement ng box is, sabi is, equivalent dun sa horizontal force na in-apply. Okay? So, ang movement natin dito. So, sabi niya is summation of F is equals to MA. So, meron tayong Fx, okay, na equivalent sa MAX at meron tayong Fy na equivalent sa MAY. Ngayon, sa Fy, ang y component lang na F natin is the normal force. However, the object is not moving up and down. So, ang acceleration natin here is 0. So, normal is equals to 0. So, wala din, okay? So, yung x component naman natin, which is the 20 Newton, okay? And then, the mass of the object, which is 40 kilogram. At yun yung hinahanap na acceleration ng box. Yung acceleration niya horizontally. So, this is 20 divided by 40. This is 0.50 meter per second squared. Okay? So, this is our final answer. Ma'am, paano po naging meter per second squared yun? Diba ang mangyari dyan, AX is equals to 20 Newton over 40 kilogram. Tama ba? And then, ang Newton kasi, diba, if you remember, that is kilogram meter per second squared divided by 40 kilogram. So, magka-cancel si kilogram, magiging meter per second squared. Okay? So, next, example number 3, a waitress shoves a ketchup bottle with mass 0.45 kg to her right along a smooth level lunch counter. The bottle leaves her hand moving at 2.8 meter per second then slow down as it slides because of constant horizontal friction force exerted on it by the countertop. It slides for 1 meter before coming to rest. What are the magnitude and direction of the frictional force acting on the bottle? So, for example, uh, ito yung table na countertop. Ito si ketchup. Okay, so for example, ito si bottle ng ketchup. So normally, meron siyang normal force, okay? At saka, frictional force, 'di ba? Kung tinulak siya or inaccelerate siya na paganyan, okay, sabi niya at constant velocity na 2.8 meter per second, okay, dahil daw sa frictional force, nag-decelerate siya. So, from 2.8 meters per second, huminto siya. So, ibig sabihin, ang final velocity is 0 meter per second. Okay? Bago siya huminto, nakapag-travel siya ng 1 meter. Okay. Tama. So, ang hinahanap ngayon is the direction of the friction force. Okay. So, summation of F is equals to MA ulit tayo. Okay? Now, ang Fx natin is equals to MAX. Ang Fx natin ay equivalent sa frictional force only. Okay? So, frictional force is equals to MAX. Ang Fy natin is equals to MA. Ang Fy natin dito is equals to N is equals to MA. However, the bottle is not moving up and down. So, basically, ang acceleration natin here is 0. So, N is equals to 0. Okay? So, ayan. Um, hanapin natin ngayon is the frictional force. Para makuha natin si frictional force, we need MA. Meron tayong mass na given which is 0.45 kg but the acceleration is wala. Pero may given tayong initial velocity, final velocity, at saka distance. So, if you remember in kinematics, we have this formula, Vf squared is equals to V0 squared plus 2A x final minus x initial, diba? And Vf squared here is 0, okay? And the initial velocity would be 2.8 meters per second squared plus 2a na hinahanap natin. And then, ang x final natin, sabi niya 1 meter. Okay? 1 meter from ang datum natin dito, malamang is 0 ang initial. So, ang A natin would be 0 squared is equals to, oops, is equals to 2.8 squared plus 2 alpha x times 1. Shift solve is negative 3.9. Okay? Negative 3.9 meter per second squared. Okay. Now, ayan, ibig sabihin ng negative 3.9 is we are decelerating, okay? Kasi ang acceleration naman natin actually is going to the right. So, uh, wala sanang problema. However, it is decelerating or slowing down, okay? So, if we are going to substitute it here, Ff is equals to mass, which is 0.45 kilogram, okay? And then, negative 3.9 meter per second squared. So, the frictional force is equivalent sa 0.45 times negative 3.9, which is equivalent to negative 1.8. Negative 1.8 Newton. Now, the negative sign here, ang ibig sabihin lang is the direction. Oh, so ang direction, 'di ba, kung ang movement is to the right, always kung ang movement ng object is to the right, ang frictional force is the opposite, okay? So, going to the left siya, so malamang kaya siya naging negative 1.8 Newton, okay? So, ganun lang ang ibig sabihin ng sign convention dyan, okay? So, yan, units of forces. Meron tayong 1 dyne na unit, 1 gram centimeter per second squared, which is equivalent also to 10 raised to negative 5 Newton. 1 pound force is equivalent to 1 slug feet per second squared. And it is also equivalent to 4.45 newtons, okay? And then, meron tayong system of units. Pag SI, ang force natin is in Newton. Ayan. Pag CGS in dyne. Pag British is pound. Pound force, okay? So, that's it. Let's proceed to mass and weight. Usually, ang mass and weight is nai-interchange, okay? I mean, napagbabaliktad, okay? Or akala nila parehas yung ibig sabihin ng mass and weight. Ang mass, guys, is the amount of matter. Okay? Amount of matter. Ang weight naman is the pulling force of gravity. Pulling force of gravity on an object. Okay. Ayan. So, iba si mass sa weight. Kasi si weight, naapektuhan siya ng gravity. So, kung ang object mo ay wala sa Earth, may iba yung weight. Unlike sa mass, kahit saan siya pumunta, yun pa din yung amount of mass niya or amount of matter. Kasi it is in terms of the object itself or the matter itself. Yung weight, it depends on the gravity acting on the object. Okay? So, weight is equals to mass times gravity. Ayan. So, let us apply it in example number 4. A 2.49 times 10 raised to 4 Newton Rolls-Royce Phantom traveling in the x direction makes an emergency stop. The component of the net force acting on it is negative 1.83 times 10 raised to the 4 Newton. Okay? What is its acceleration? So, halimbawa meron tayong kotse. Okay, simple lang naman to, hindi naman na kailangan ng FPD dito. Pero gusto ko lang ipakita yung sign convention. Sabi niya, at 2.49 times 10 for Rolls-Royce Phantom. So, ibig sabihin parang ito yung sinasabi niyang weight. Okay. Yung 2.49 times 10 raised to 4 Newton. Okay? And it's traveling sa x direction. However, it makes an emergency stop. So, habang nagte-travel siya, bigla siyang nag-stop. Okay. In order to stop, okay, kasi the X component of the net force acting on it, ibig sabihin, merong pumigil sa kanya. Okay? Kaya siya nag-stop na ang force is negative 1.83 times 10 raised to 4 Newton. What is its acceleration? Actually, this is not acceleration. This is supposed to be deceleration. Pero okay lang. Ibig lang sabihin that is negative acceleration. Okay? Deceleration kasi from a moving to lesser velocity or sudden stop. Okay? So, ang hinahanap dito is the negative acceleration or the deceleration. 'Di ba? Ang F is equals to ma. Ito 'yon. However, we have a given of weight, mg. Okay? Weight is a pull of gravity, so g. Now, alam natin si weight na 2.49 times 10 raised to 4 Newton. G, alam natin, nasa Earth siya, 9.8 meter per second squared. Okay, so ang mass ni car is ang mass ni car is equivalent sa 2,540. 2,541 kilogram. Okay. Yan. Now, alam na natin si mass, so we can actually substitute it here. Ayan. So, pag sinubstitute natin dyan, so, negative 1.83 times 10 raised to 4 Newton, okay, equals mass which is 2,541 kilogram acceleration, okay, negative 1.83 exponent 4 divided by 2,541. Yan. So, the acceleration is negative 7.2 meter per second square. Yan. So, negative siya kasi it is slowing down, negative acceleration or deceleration. Ayan. Okay. So, ayan. So, let's proceed to the third and the last Newton's law of motion. Okay. The third law of motion states that if body A exerts a force on a body B, an action, then body B exerts a force on body A reaction. These two forces have the same magnitude but are opposite in direction. These two forces act on different bodies. So, kung familiar kayo dun sa Newton's third law of motion na in any action, there is always an exact but opposite reaction. Okay? So, ayan. For example, the force A on B is equivalent to negative force B on A. Okay, equal sila pero magkaiba ng direction. Ayan o, negative. So, for example, here is the a a foot and a ball. Okay. Etong force ni foot sa ball, okay, is this one. Ito yan. Kasi ang foot natin is, let's denote it as A and then B yung ball, okay? So, ang force ni foot to ball is ganun ang direction, okay? However, si ball, meron din palang force na ina-apply which is equivalent to the magnitude of the force that A given to the B. However, the direction is opposite. Okay? Same magnitude but different direction. So, ganon ang Newton's third law of motion. Okay? So, for example, we have an apple placed on a table. Ayan. Meron tayong force acting on the apple. The force table, the force of the table on the apple. Okay? May force yan. Ang tawag dyan is yung normal force, 'di ba? Sabi ko sa inyo kanina, any object placed on a surface is merong normal force. So, ito yung normal force. And then, the earth on the apple. Okay? So, malamang ito si weight. Si weight at saka si normal force. Ayan yung the forces acting on the apple. So, kung magko-concentrate muna tayo dun sa weight, ayan, merong force na weight or the force of the earth on the apple, pero meron din palang ine-exert na opposite force si apple on earth. Okay? So, may opposite force pero same magnitude. Okay? And then, ayan, kung magko-concentrate naman tayo dun sa force o yung normal force ng table, ayan, ito yung normal force natin kanina. Meron din palang opposite force ng apple dun sa table mismo. Okay? Ayan. Meron siyang, yung apple merong force na ine-exert dun sa table. So, yan yung opposite forces niya. And then, pag inalis naman natin si table, okay, i-remove natin si table. So, wala na yung normal force natin sa surface. Meron na lang is um, yung weight, which is the force exerted by the earth on the apple, at saka yung reaction niya na apple and the earth. I mean, um, the force exerted by the apple on earth. Now, sabi dito, the two forces on the apple cannot be an action-reaction pair because they act on the same object. Okay? Ayan. So, ito daw, si weight, the earth on the apple. On apple and apple on earth. Ayan. Sabi niya dito, the two forces on the apple cannot be an action-reaction pair because they act on the same object. So, ito ha, etong table on apple tsaka earth on apple, hindi siya pwedeng action-reaction. Kasi they are exerting forces on the same object. Ang pwedeng maging ang pwedeng maging action-reaction pair is yung opposites. Earth on apple, apple on earth. Table on apple, apple on table. Okay? Yung opposite siya, yung nag-a-act yung forces oppositely. Halimbawa, force on A to B, then force, ang pair niya is force of B to A. Okay? Pero yung table on apple and earth on apple, hindi pwede siyang action-reaction pair. Okay? So, that ends our lecture for uh, lesson number 1 of module 3. Thank you very much.